So this lesson is to derive the identities for the sine of a sum of two angles, or the sine of a difference of two angles. So when I'm doing sine of the sum, I'm going to go ahead and use those cofunction identities with this time the angle that we're going to use is alpha plus beta. So we saw before that the sine of anything is the cosine of pi halves minus that thing. So in this case, the angle in question is the sum of two other angles. Maybe call it theta just to get a sense of, okay, so sine of theta is cosine of pi halves minus theta. In this case, theta is alpha plus beta. It's the sum of two other angles. So all right, this next move to me is super clever. So what they said is, well, all right, just wiggling around on what's going on inside. So that's pi halves minus alpha minus beta, just distributing that. And what I'm going to do is say, okay, that's the cosine of pi halves minus alpha minus beta. So kind of rearranging who we're who's doing the association. There's a little bit of order of operations. At first up here, I said, all right, alpha plus beta, that's one chunk. But then once I distributed the negative sign, multiplied both alpha and beta by -1 using distributive property, well, it's just three terms, pi halves minus alpha minus beta. But then said, okay, well, we could, without changing the value of this thing, think of, I'm going to do pi halves minus alpha as my chunk. That's the first thing, and then I'm going to subtract beta, the other thing. But now I have the cosine of the difference of two angles, and that's going to be cosine of the first times cosine of the second, plus, remember when you do the cosine of a difference, you're going to have plus sine of the first times sine of the second. But we just got done doing a bunch of cofunction identities. Cosine of pi over 2 minus alpha, that's just sine of alpha. Cosine of beta, I'll just call cosine of beta. Sine of pi halves minus alpha, that's cosine of alpha. And then sine of beta, I'll call sine of beta. So this is cool. I now have a formula that says the sine of the sum of two angles is equal to, and let's just be careful what we're doing, sine of the first, cosine of the second, plus cosine of the first, sine of the second. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. And you'll notice that the plus or minus, I'm adding angles, and so I'm got a positive here. Unlike with cosine, we had to switch signs. No, with sine, it's the same plus or minus, same sign, sorry. Sine S-I-N-E versus sine S-I-G-N. Gets confusing when you're speaking, but anyways. So yeah, we have this new identity that now we can deal with sine of a sum. And if I were doing sine of a difference, I'll just be kind of clever about that. And hey, I wasn't the one that was clever here. I just learned what somebody else did. But I feel like this is pretty darn clever. So they said, oh, that's just, minus the opposite. If I have minus the opposite of beta, regardless of whether beta is a positive angle or a negative angle, if I subtract, and I just screwed that up, that would be plus, right? If I add the opposite, that's the same as subtracting. It's the same as subtracting. So I haven't done anything algebraically wrong, regardless of whether beta itself is positive or negative. But now I'm going to use the new thing we just had. So it's, sine of the first. The second one now here is going to be negative beta, but sine of the first, cosine of the second, plus cosine of the first, sine of the second, and then we have to remember about odd and even. So the cosine function, when I'm looking at x-coordinates, if I go one direction with an angle and look at its x-coordinate, it's going to be exactly the same as if I go the other direction with the angle. It's going to be exactly the same x-coordinate. So cosine of minus beta is the same as cosine of beta. So I'm going to replace it with that. On the other hand, if I'm looking at y-coordinates, if I went forward and got a y-coordinate, now when I go the other way, it's going to be exactly the negative of that. So sine of negative beta is going to be minus sine of plain old beta. And so I'm just going to say, all right, so there's a negative here. And we have a whole new identity. That sine of a difference is the sine of the first cosine of the second minus cosine of the first sine of the second.